All right, now we want to complicate our ideas of stoichiometry by looking at when we start to involve grams. So we ended with this idea that we have this new conversion factor to add to our roster of tools. These are the tools that we can use to relate different quantities in chemistry. And so this molecular formula, Avogadro's number, molar mass, or what we had previously, and now we've added reaction coefficients. The reason why we put them all in the same idea is that these two reaction coefficients and molar mass are going to be intimately related together. Reaction coefficients is the only tool that we have to convert between species between substances in a chemical reaction. But they only work in counting units. We only can use them with moles. The most common way that we measure amounts in life is mass. So it is oftentimes you want to know you have a mass of reactant and you want to know a mass of product. But you can't relate those masses just using reaction coefficients. You need to convert them into moles. So we're still going to be using our molar mass. How many grams of copper can be produced from 15.6 grams of silver in the following reaction? 2Ag plus CuSO4 becomes Cu plus Ag2SO4. So if we start by asking what do we want, it is going to be grams of copper. We want a mass. Another quick note, as we move forward, this one explicitly tells you want grams. Anytime you are asked a question where you want an amount, unless you are explicitly asked for moles, you can assume that mass is the unit that you want. How much is another good indication that you want mass. Okay, but what information do we have? Well, if we read, we can see that how many grams of copper can be produced from the 15.6 grams of silver. So we can see that what we're doing here is we have a mass of reactant, and we want to figure out from that a mass of product, right? I measured out on a scale, I got silver, and I want to figure out a mass of product. The reason why we want it to be mass is because other applications of copper probably describe the amount by mass. If you look at selling copper, for example, the price is by ounce, which is related to mass. That's just a customary unit for mass. And so you can relate it to ounce, mass, right? Those are the kind of things you want to get it into. Moles, not really a useful unit outside of the chemistry lab. And so we are dealing with this mass of silver. That's what our starting amount is. We want to get it to mass of copper. And so we know we want to relate different substances using our reaction coefficients, right? If I want to go from silver to copper, those are just entirely different elements. There is no general relationship between amounts of those things. It is uniquely defined by this chemical reaction. So that chemical reaction is where I'm looking at the relationship, because this is how I'm doing a reaction involving these different elements. The thing is, those coefficients only work in counting units, and everything so far is in grams. So what I will need to do is use my molar mass to convert, basically to translate between the mass representation, which is more useful outside the chemistry lab, and the mole representation, which is extremely useful and necessary for using these reaction coefficients to convert between amounts of different substances. So let's go take a look and see how that works. How many grams of copper can be produced from 15.6 grams of silver in the following reaction? So I'm going to start with some amount of silver, and I want to know how much copper I get out of it. How many grams? And so that idea that we can pull out right there, we know we want to relate these two things. Silver is a reactant, copper is a product. Okay, so we could imagine we're going to set it up. 15.6 grams of silver. And we know in the end we wanted grams of copper. All right, so we could try to follow what we've seen previously, where we could just take reaction coefficients to, say, grams of silver. That would work out. And then there's an implied 1 right there. And so far, that looks so good. But we cannot do that. We cannot put reaction coefficients with grams, right? Reaction coefficients come from balancing. And balancing comes from counting, okay? Balancing comes from counting individual atoms. So these reaction coefficients, if we want to use to relate silver and copper in this reaction, these reaction coefficients have to apply to counting units, namely moles. So the relationship that actually exists is that 2 right there means 2 moles of silver is equal to 1 mole of copper. That is the relationship we can use whenever you're relating different substances via a chemical equation using those coefficients. It has to be in counting units, commonly moles. You could also do it in atoms or molecules or something like that. But generally, you know, mole, with the whole reason to have moles, it's the reasonable amount of stuff. So that is not going to work. Nothing like that. We never want to use those coefficients on those grams. Never. But if we do have a little bit more, 15.6 grams of silver, we can see that what we can do at some point in time is we can think about, we want to get out of silver and into grams of copper. And so this part right here would be something along the lines of, you know, it has to be in moles. So there's going to be 1 mole of copper for every 2 moles of silver. And we know that those are the reaction coefficients. That's what we can use. In that case, they always have to be tied with moles. So there's your reaction coefficients. So we can only do those in moles. So we can say, well, this thing right here, we need to get rid of the grams of silver, so that's on the bottom. The top then has to be moles of silver. So this should be something that will allow us to go between grams and moles. Okay? And that has a name. That is called molar mass. And it's specifically the molar mass of silver. Similarly over here, moles of, Cu to grams of Cu, and that is the molar mass of Cu. And so molar masses are something that we have talked about before, we worked through before, and we know that we can look them up on the periodic table. These are just elements, and so silver is, Ag is 107.87 grams per mole. And so we know that what happens is the bottom next to grams is where we put that 107.87. 1 goes next to moles. Copper is, we can look it up, and we're just pulling these off the periodic table, 63.55 grams per mole. So the 63.55 grams goes right there, and the 1 mole goes right there. So this molar mass, we can see, well, functionally what we're doing is we take the mass of silver, we turn it into moles of silver. Then once we're in moles, we can do use our reaction coefficients, get into moles of a different substance, in this case copper, and then use the molar mass of that to get into grams of that thing. And this would be functionally what's useful, right? That's practically useful because that would tell you how much actual mass of copper, which is generally how we think and talk about materials. And so, so that would be a useful, kind of description that we would have. And in general, when we're doing stoichiometry, where we're going from grams to grams or between mass values, this 1, 2, 3 step process is going to be generally what we always use for that. A couple quick notes that tend to trip people up. The coefficients stay right here. The coefficients stay right here, right here. But when we're using molar mass, this is always going to be, the molar mass is defined as grams per mole. So that's always going to be a 1
next to those moles. So it's always going to be whatever number it is and then the 1. Sometimes folks want to take this coefficient and put it right here, but we don't want to do that. The coefficient is right here. This should be 1 mole for however many, whatever the molar mass is, 1 mole for whatever the molar mass is, and the coefficients just stay right there. Again, these are exact numbers. Your coefficients are exact. Your per moles are exact. So that's what, 5 sig figs. That's 4 sig figs. So we're rounding for 3 off of that. And we get 4.60 grams of copper. So if you start with 15.6 grams of silver, you can get 4.60 grams of copper. Not exactly the best return. You'd probably not want to use this method. That's a lot of silver to get not a lot of copper. And it's because of that 2 right there. It really kind of kills it for you. But we can now work through stoichiometry. This is kind of this archetype of using molar mass, reaction coefficients, molar mass. We're going to see again and again and again. There's a lot of more complicated dressings around how you apply that, but this standard protocol of using molar mass, reaction coefficients, molar mass is the standard way that we're going to use to do the standard method to do stoichiometry calculations, and we're just going to apply it in a couple different ways. But this is the standard kind of path we want to learn how to do.
Participation 615, question 2. How many grams of nitrogen are required to produce 7.50 grams ammonia? The reaction N2 plus 3H2 yields 2NH3, and I'm giving you the molar masses for N2H2 and NH3. This is the second question on participation 615, due Monday, June 15th at 11:59 p.m. over on Blackboard. Link to the assignment is right below links to these videos. Again, how many grams of N2 are required to produce 7.50 grams NH3? N2 plus 3H2 yields 2NH3 is the reaction, and molar masses are given for N2, H2, and NH3. All right, so stoichiometry overall, the kind of process we're going to see is this 3-step process where, it is very common that we start with grams of something and we want grams of something else, A to B in this case. The stoichiometry, the actual change using reaction coefficients, only goes from moles to moles. Right, that's the only unit where we can use those reaction coefficients, really any counting unit, but moles is the only thing we're going to see. And so we need to kind of have these wrappers of using the molar mass to do grams into moles, and then molar mass of whatever else we want into grams of whatever else we want. If you can sometimes, you're interested in the mole information, moles of this becomes moles of that, and you can do all these conversions, but really overall, functionally, all that's useful, and really what I'm going to focus on asking is being able to go all the way from grams of one thing to grams of another thing. Experimentally, that's what we would want. Functionally, if any sort of real world application, that's the overall change you want, and it's always going to be 3 steps. As we move forward with the rest of this discussion, we're going to look at some more complicated versions of stoichiometry, or kind of different applications where we're looking at stoichiometry. And so there'll be other kind of work surrounding this 3-step process, but each stoichiometry calculation is always going to be these 3 steps. Some problems will have to do 2 or 3 of these steps, but we're always going to do this kind of basic approach to the stoichiometry conversion.